Hi, this is Andrea Hendricks, and I want to talk with you about absolute value equations. Let's start by reviewing the definition of absolute value. The absolute value of a number refers to the number's distance from zero on the real number line, and we use vertical bars to denote absolute value. Do you remember, like, the absolute value of -5 is 5, since -5 is 5 units from zero on the number line. The absolute value of 5 is also 5 because it is 5 units from the number line. I'm sorry, 5 units from 0 on the number line. Absolute value will not equal a negative number, because absolute value refers to distance. It doesn't make sense for the absolute value to be negative. So you really want to keep that in mind as we're solving absolute value equations. So let's talk about solving these absolute value equations. If I want to find the values of x such that the absolute value of that number is 5, this basically means what numbers have an absolute value of 5? Well, we just looked at that. We know that either x is equal to -5 or x is equal to 5 have an absolute value of 5. So our solution would be plus or minus 5, or you could write them separately as -5 and 5. Right, how do I know that's right? If I plug it in, absolute value of -5 is 5. The absolute value of positive 5 is 5. What numbers have an absolute value of 3? Well, that is 3 and -3, right? The absolute value of positive 3 is 3. The absolute value of -3 is 3. What numbers have an absolute value of 7? We would say 7 or -7 to get a solution set of plus or minus 7. The last one, absolute value of x equals -2, is saying what numbers have an absolute value that's -2. Well, we just talked about that. The absolute value is always positive or perhaps 0, but it's never a negative value. And so this one has no solution. Because if you plug in, let's say you think it's 2 and -2, if you plug in -2, the absolute value of -2 is positive 2. It's not -2. If I plug in 2, the absolute value of 2 is positive 2, not -2. So I can never get a solution for that. So we write that as the empty set. So really we have a property that allows us to solve absolute value equations. It says if we have the absolute value of a number, that x can be a number, an expression, whatever. If the absolute value of some algebraic expression x is equal to a number a, where a is positive, then either x is a or negative a in all those examples that we just saw, except for the last one. If the absolute value of x is equal to 0, well, the only way that's true is if the inner expression is 0. If the absolute value of x is equal to a, where a is less than 0, that means where a is negative, then there is no solution. Okay? So this actually says a few things. If we have to isolate the absolute value, and then if the absolute value is equal to a positive number, there are 2 solutions. If it's equal to 0, there's 1 solution. If it's equal to a negative number, there are 0 solutions or no solution. Okay? So if we wanted to solve the absolute value of x minus 5 is equal to 2, this means thinking about this. What has to be in here for the absolute value to be 2? Well, that expression inside has to either be positive 2 or negative 2. Oops. So we would add 5 to get x is equal to 7, or if we added 5 again, adding 5 to -2 gives us 3. So it's saying 7 and 3 are our solutions. What can we check? We plug in, is the absolute value of 7 minus 5 equal to 2? Yes, because that's the absolute value of 2, which is 2, so that checks. If we plug in 3, is the absolute value of 3 minus 5 equal to 2? Well, that's the absolute value of -2, but that also equals 2. So our 3 and 7 are correct solutions. the next example, to solve absolute value of 2x minus 1 is equal to 5, well, for that to be true, the number inside here has to have an absolute value of 5, which would be either positive 5 or negative 5. So we're going to add 1 to both sides to get 2x is equal to 1. Not 1, 2x is equal to 6. Dividing by 2, x is equal to 3. If we add 1 on the other side, or other equation, we get 2x is equal to negative 4. Dividing by 2 gives us negative 2. So our solutions are negative 2 and 3. And you could check by plugging in. If we plug in the negative 2, 2 times negative 2 minus 1, well, 2 times negative 2 is negative 4, minus 1 is negative 5, but the absolute value of negative 5 is 5, so that checks. If we plug in 3, 2 times 3 is 6, minus 1 is 5, and the absolute value of 5 equals 5, so they both check. More examples here. If I have absolute value of x minus 1 plus 5 is equal to 3, this is written, the value is not isolated. So I've got to isolate the absolute value first. So I'd have to subtract 5 from both sides. I cannot combine things that are in the absolute value to things that are not, so don't try to simplify that expression anymore. I've got to get this whole absolute value on a side by itself. So I would have absolute value of x minus 1 is equal to negative 2. But if you're paying attention here, we know that has no solution because there's nothing I can put in for x so that when I take the absolute value I get a negative. So anytime absolute value isolated is equal to a negative number, there is no solution. For the next example, I'd have to add 4 to isolate the absolute value. So I'd have absolute value of 1 minus 3x is equal to 11. This one has two solutions since the absolute value is equal to a positive number. So I have to set 1 minus 3x equal to positive 11, or 1 minus 3x is equal to negative 11. Again, the thing I'm setting it equal to is what values or what numbers have an absolute value of positive 11, and that is 11 and negative 11. When I solve it, I subtract 1 from both sides to get negative 3x is equal to 10. Dividing by negative 3, I get negative 10/3. If I subtract 1 from the other equation, I get negative 3x is equal to negative 12. And dividing by negative 3 gives me x is equal to 4. So my solutions to this are negative 10/3 and 4. Okay. Now, how can I use the calculator to check my work? When we solve an equation, we're really solving a system of equations, if you remember, and the solutions come from solving the system by graphing, that is where they intersect each other. And so if I'm trying to solve absolute value of x minus 5 is equal to 2, I can input each side of the equation into a separate equation. So in the calculator, absolute value of x minus 5. Now to get absolute value on the calculator, you have to press the math menu, use your right arrow key to the number menu, and then select number 1, which is ABS. Okay. And then I input 2 on the other side. Now absolute value of x minus 5, we haven't really talked about the graph of that, but any absolute value of a linear expression is going to be a V-shaped graph. We know what y equals 2 is. That's a horizontal line. So notice there are two places where these intersect. What are the x values there? They are at 3 and 7. And if you recall, we did that before where we said x minus 5 equal to 2, or x minus 5 is equal to negative 2. If we add 5, we get 7. Or if we add 5 to negative 2, we get 3. So the x values of where they intersect are the solutions to this equation. So we know we have two solutions. So if you have any questions on this, please contact me. Thank you.